Namaskar. Welcome to Prakash on Basics. I'm Prakash Zog, and we've been talking of light. Humans have put every property of light to use for their own benefit. Uh, Today, we are going to talk of one of these, which is reflection of light. At the boundary of any medium, light waves turn back into the same medium. This phenomenon is the one that is known as reflection. Actually, when light falls on an object, three things can happen. The light can get reflected, or it can get absorbed, or it can go right through, which is transmitted. Uh, Naturally, um, not only one, but a combination of these three can also take place. So, substances can be either good reflectors or bad reflectors, good absorbers or bad absorbers, good transmitters or bad transmitters. For example, metals are good reflectors. Um, they also tend to absorb light if possible, and they don't transmit light at all. You could have many other substances like glass, for example. It transmits a majority of the light that falls on it right through. So there could be, or you could have human hair, in which case all the light that falls on it gets absorbed and nothing is reflected or transmitted through it. So black objects tend to absorb all quantities. We today are going to talk and concentrate on the reflected part to a greater extent. Naturally, as a part of science, reflection has its own laws and they are all based on geometry. And surprisingly, that is the first thing that we've learnt in school. I'll just remind you of these laws. They are not really very difficult to grasp, even in a few seconds. Uh, Realize that a ray is the direction in which a light wave or its energy travels, or what is known as propagates. Usually, this is a straight line and it radiates outwards from the point of source. So, if I have a bulb, rays will be going out in all possible directions. It is these rays that are talked of when we talk of these laws. What you need is a reflecting surface, let's say like a mirror. It has to be flat. So let's say I have a flat surface, then draw a perpendicular to it, that is at right angles. This is typically referred to as the normal. Then the ray of light uh, comes at some angle and falls on it. The angle that is measured is the one with the vertical here. This is known as the angle of incidence. And the ray, after hitting, is going to turn around and move in another direction. And then it's going to make another angle. So the reflected ray makes another angle which is known as the angle of reflection. Now the laws are very simple. The laws state that the angle of incidence is equal to angle of reflection. So whatever way the light falls, it's going to get reflected in the same possible pattern. And the ray won't turn back like this. The incident ray and the reflected ray are always going to be on either sides of the normal. And the third simple thing is not going to fall like this and then suddenly turn this side. So the incident ray, the normal, and the reflected ray are all in the same plane. It's very simple. Angles remain the same. They are all in the same plane and they are on either sides of the normal. These are the laws. And they are all based on pure geometry. And like what I told you last time, these geometrical optics part is what we've always used to even study all possible reflection that takes place. Uh, these laws can be modified for other surfaces other than the ones that are flat or plane. But today, in the beginning, we will talk only of the flat surfaces. If the surface is perfectly flat, then the reflection is said to be regular reflection. In such cases, images can be clearly be seen or formed. For example, if you, the earliest one, which is just take a bowl of water, and if you look at the water surface, you would see a reflection because the water surface is perfectly flat because of its surface tension. But if it is slightly wavy, or if there are pits and grooves, or it is non-uniform at a microscopic level also, then the surface which is uneven results into irregular reflection. So if you have two or three parallel rays on a flat surface, they will remain parallel as they go across and create an image. But if it's the surface is irregular, it's got pockets and pock marks and so forth, then even at a microscopic level, then no image can be formed. For example, if you look at a wall, this behind is not going to form an image. The ground that we know of is not going to form an image. A wooden surface is not going to form an image. But quote that highly polish that wooden surface, and what you are doing is flattening it out perfect, or fill up all the cavities by using some pigment or some material, and then you will start seeing an image. So regular reflections are going to result into image formation, and irregular surfaces are not going to create images. And so for reflection, mirrors are the most important applications of reflection. Uh, we have to understand quite a few simple things that we take for granted but are not really many times right as far as mirrors are concerned. Um, the earliest reflecting surface that was used is obviously the one I just mentioned, which is water surface. And these were possibly the first ever mirrors that were used. Then, long back in ancient times, also, there used to be volcanic glass. It is called obsidian. It's usually dark, bottle green, or this sort, or black, but it's got a very fine, polished surface. And these pieces can act as good mirrors or reflectors. After this came the metal mirrors. When metal surfaces are highly polished, they start acting like mirrors. And they could be pure metals or they could be alloys. And such substances are typically referred to as speculum substances. In fact, in India, in Kerala, such mirrors have been made traditionally for quite a few years, and they are still being made. And they are highly sought after and they're pretty costly. There are traditional makers of these mirrors. They are known as Aranmul Kannadi. They are a part of the bride's 8 objects that are given along with her when she gets married. So it's a marriage package, but these are extremely costly mirrors. The composition is an alloy, usually tin and copper. And special families have their own trade secrets and manufacture these mirrors. And it takes various ingredients to polish the surface to its perfect brightness. And these metal surfaces then remain as very good mirrors for a very long amount of time. Naturally, they are going to be very costly. But one more thing must be remembered. It is the front surface of this metal that acts as the mirror. So these are first reflection or front reflection type of mirrors. In many Indian sculptures, we can see these handheld mirrors, and these sculptures are pretty ancient. So you would find that mirrors have been in use in India for a very long time. It is around before Christ or just after that, in the first century AD, that glass began to be used for making mirrors. Uh, Realize that glass is not the mirror. The metal coating that is used behind the glass is the one that is the mirror. But then why do you need to use glass? Because it's a very good base. Uh, it is extremely transparent, as I mentioned in the beginning. Only about 4% of light gets reflected, and a majority of it gets transmitted right through glass. A part of it can get absorbed, but that fraction is pretty small. Um, it's also free of all pits. So when you make a glass, it starts as a fluid and so settles down and becomes extremely flat. So there are no pits and bumps. So the base on which the coating is made is perfectly flat. A perfectly uniform layer of metal can be applied on one of the sides of glass. And so a distortion free image can be obtained if you use glass as the surface on which the metal coating is made. Actually, around 500 AD, the Chinese started making such mirrors with silver and mercury amalgam. Amalgam is not just a mixture, it's like one metal dissolving into the other. So that's typically what an amalgam is. Uh, and this using glass mirrors started off from there and it spread very easily. Trade secrets don't remain and they were copied, and to a very large extent, uh, this idea of glass making transferred from China to Venice, which became the center of European glassmaking for a very long time. The Venetians claim that they are the ones who started it, but to be very frank, it originated in China, even the colored glasses and others. But the Venetians used silver and tin amalgam, and the surfaces then formed of glass were better and more reliable. And so Venetian mirrors became quite popular. Uh, Naturally, instead of polishing a metal, this whole thing would bring the cost down to a large extent. And mirrors then started becoming a part of uh, things for the rich to a large extent, gradually becoming a part of their utility. But then using mercury is dangerous because mercury is toxic. Uh, so other attempts were also made. Around 1835, a German scientist named Liebig invented silvered glass by using deposits. The idea was to coat the silver with, I'm sorry, the glass with silver nitrate, and by using a chemical process, reduce it down to a very thin film of silver. Once this could be done, um, the production of mirrors started increasing to a large extent. Mass production was also possible, and mirrors then started getting cheap. But then at that time, many a times silver was used, mercury was also used. Um, Today, of course, mostly silver, and in many cases, aluminium deposits are used on the backside of the glass. Sometimes gold is also used. Chromium, which is extremely glossy in surface, is also used. Around before 1940, mercury was used quite often. Silver also was extensively used. Now, of course, things have changed. The coating materials are chosen based on the durability that is expected, the amount of reflectivity that is expected, the purpose of the mirror, because for scientific purposes, silver or gold sometimes is used. Um, so, how do you make all this commercial? You have very large sheets of glass. They are designed and made perfectly flat, polished and cleaned, so that they are free of pits and free of any oils or contaminants, because then they are going to damage the film that is deposited. One more aspect, silver doesn't directly, or mercury doesn't directly stick to glass. So what do you do? So initially, uh, tin chloride deposit is made on the glass surface, and then a coating of silver nitrate or um, aluminium nitrate or similar compound is put again on top of this tin chloride. What happens is then a new bond is formed between the tin and the metal that is being deposited, and gradually the film becomes extremely polished surface on one side of the mirror. This process is typically referred to as the wet process, but the film is extremely fragile and delicate. So, in most cases, another coating of copper deposit is made on top of this. So the film gets a hardness, and then two paint coats are added. You have to apply paint, bake it, again apply paint and bake it, and this makes the backing perfectly free of pockets, cavities, and is safe and can be retained. And the light is going to fall through the glass on this polished surface, which acts as the mirror. There is one more issue in this. It's possible that some amount of light is going to get reflected from the first surface of glass itself. And if you look at old thick mirrors, Belgian glass, and so forth, you will find that you see two images. The first image is front reflection of the glass, and the second is from the silvered surface behind. So, most mirrors are actually secondary image or the second image type. The first front reflection, though very weak, can sometimes be troublesome, especially for scientific applications. Uh, if you're going to use visible light, like normally that we do, we tend to use aluminium as the backing. But if you have to study substances like infrared light, then the coating behind is of gold. Then there are special mirrors that are also created. You have concave and convex mirrors. Convex mirrors are quite common nowadays because you have them in as the mirrors that are used in cars, so that the image appears in the convex mirror and is reduced and small in size and covers a very large area from behind. Though there is a warning, the image is small and it's actually much closer than what it appears to be. Concave mirrors are also used, and their typical use is in what is known as reflection telescopes. I'm going to come to that when I'm going to talk of telescopes, and this has a special hitch in it. I'll discuss that when we come to those. There is also a tendency to coat the film in a very thin layer, which makes it a partially coated mirror. And such partially coated mirrors are like the ones that are see-through mirrors. So from one side, you can look on the other side, which is illuminated. And if you are standing in the dark, you would not be seen, but the other side would be seen because light from there would fall partly on the surface, get reflected back, creating the image that you need, and your light would not go through and create or make others aware of it. So these are partially or partial mirrors. They are also specifically used in lasers. Uh, Scientific applications that we talk of, the glass has to be processed in the beginning. It has to be made circular and so forth, and concave or convex or curved and so forth, and then polished and refined and deposited. There are different techniques that are used to deposit such front coated surfaces or special mirrors. Generally, we always talk of flat mirrors because they are the most common. And in these mirrors, there are a few things that we must realize. One very important thing is that there is what is known as lateral inversion. which means that the way in which the image is formed, the left original appears in the mirror as right and vice versa. It depends upon how you place the mirror. So if you place the mirror on top of an object, up will appear down and down will appear up, because what is far away will remain far away and the image would seem to be inverted. Um, I remember designing a lot of questions of this sort um, for mental ability tests. You could try some of them. Um, take a think. Uh, think of capital English alphabet and see which of these would appear to be identical alphabets with the mirror next to it, with the mirror covering half the letter, or the mirror above or below the alphabet. So you have A mirror to this side, A mirror below, or mirror on top, or partly halfway covering A, and check which of these alphabets would appear to be the same, including the, or rather in the image. And there are so many beautiful designs that can be obtained. And this, in fact, is one of the applications that is often talked of. One more thing must be realized. We have mirrors that reflect only our face, but many a times you are interested in seeing the full size. And based on the laws of geometry, depending upon the image which is exactly equidistant behind, means that if you want to see a complete image of yourself, the height of the mirror must be at least half the height of the person. That's a part of geometry. But if you have mirrors smaller than that, either your feet are missing or you may not be able to see a part of your head and so forth. Then there is one more issue. There are a lot of places where we see mirrors, not one, but two of them, and they are inclined or angled out to each other. Now, such situations of angled mirrors result into multiple images. The rule for this is that depending upon the angle, the number of images will be seen. If you have a 90-degree angle between the two of the mirrors, then you would see three images. If the angle is 60 degrees, you would see five images. Why these odd numbers is quite simple. It depends upon the way in which a mirror results into symmetry. Because if I have a mirror here, whatever is on this side will exactly identical would be seen on the other side. So it's one single symmetry that is obtained. And it's possible that if you have a pair of mirrors, then the symmetry axis that you see would be split up. And so if you have 90 degrees, what happens is there is a fourfold symmetry. Because in this mirror you see a reflection of this, and in this mirror you see a reflection of the other, and if you look carefully you would see a total of intersecting set of mirrors, and each of them will produce an image. But there is an original object. So the object 1, 2 and 3. So you see three images. So if the total angle that we know is 360 degrees, 360 upon 90 minus 1 will give us the number of images you will see. Same way, if the angle is inclined to 60 degrees, then 360 upon 60 is 6, one original object. So what you are going to see is 5 images. And then humans have always been shrewd. They have used multiple mirrors. And that has resulted into one of the most common toys that we know of, which is known as the kaleidoscope. So what you do is you put two mirrors at an angle of 60 degrees and put one more mirror at the side. And if the mirrors are of the same size, you are going to get 60, 60, 60. And the result is that in each of them, there would be 5 more images produced. And there would be multiple reflections. And all these will be symmetrically placed. And so you would see a beautiful design. And that's what a kaleidoscope is. And then there also people realize that there is no real need to use mirrors. You could use just glass sheets, and even the partial reflection of the images is good enough if the whole thing is encased to provide the necessary beautiful designs that we know of. And that's how a kaleidoscope works. And there are so many others. A periscope, for example, is a tool that was used to see objects at a much higher height initially and later on applied even in submarines. So you have one mirror that's kept at one angle and a second mirror kept exactly below at another angle, but the two of them are parallel to each other. So the ray comes from here, falls like this, and goes out on this side. And the object that is here can be seen by a person here. So you are below water surface and you can still see an object which is higher than the water level. And that's how periscopes were designed. But you can't have an open tube. And so things got modified. And it wasn't just putting mirrors, there are other things, and I'll come to that sometime. So you have periscopes and kaleidoscopes and concave mirrors and convex mirrors. And the shaving mirrors, they are all concave mirrors because they tend to give a magnified image. A convex mirror is used to get a diminished image. So there, and if it's a wavy glass, then you get a completely distorted image. So this is how images are produced. And reflection is the basic principle on which all this is based. One more thing that I must point out scientifically. All mirror images, except for concave mirrors, are said to be virtual images because the rays don't actually cross across and meet at that time point. These images cannot be obtained on walls. You cannot project them. So these are all virtual images. Concave mirrors and convex lenses and others can produce real images, but we'll come to that when we come to those other areas. So that's how reflection works. Realize that when I talk of reflection, I'm talking of images to a larger extent. And man has used reflections to a very large extent in so many different applications. But there are many other applications in other areas of light too. We'll come to them next time. If you have liked whatever I have said, please like and subscribe to this channel. Next time you look into the mirror, realize that you are looking at a virtual image of yourself, which has a left-right shift, a distortion of some sort, and the intensity is not exactly the same because there is a partial reflection. Look at thick mirrors and see if you can detect the second image also. Till we meet again to look at the next major property and applications of light. Namaskar.